how's everyone doing? Good to see you here. Nice job, Blake, right there. Haven't even seen it yet. What's going on in the chat? Evan's here, Blake's here. Let's go to live chat. We got Mewbot waking up. Mewbot's awake in the chat. That means we're dropping some points. What questions are there? Can we do number 14 on the practice exam? You got it, Muskin. Let's do it. First question of the day, or number 14 on the practice exam. Can we get 125 points thrown out? 125? Sure, let's do it. Points, add, plus viewers, 125. There you go. What other questions are? We'll throw 1,000 points on top of that. We got number 14 on the practice exam. Let's pull that up. Good to see everyone here. Drop those questions in the chat. Let's throw some birthday points in the chat. 2,000 points for the birthday points. How's everyone doing? Got a bunch of people here getting a ton of points. I love it. People watch the levels and like to see the levels go up. We added a new level today. We added snail level. So we're going to go to the exam right here. Practice exam is in the chat. Let me download the practice exam. Can we go over percentiles? Yeah, we can do some percentiles. Show all. Show in folder. Here we go. Adobe Acrobat. Percentiles, library GG easy. So we need some R help. Let me write this here. We're doing Stat 201. Tag me with the questions. Stat 201, Exam 1, Practice, Question 14. Stat 201, Percentiles on the curve. Still Exam 1, Practice. And Olivia wants BS320, loading libraries. Anything else? Need help on assignment 5, associations part 3? And what are you wondering about, Jackson? Let me know what you're wondering about, and we'll do that here soon. Whatever you're wondering about, let me know how to do correlations, which also crosses over to 101. Drop those questions in the chat. We're going to start here with the first question asked. Remember to tag me. Question number 14 over here on the practice exam. Let's go check it out. So here we are. Disregard. I don't know. Everyone in the library right now. Here we are with number 14 on the practice exam, 310, right there. So below is a pivot table showing the average rate. Let's take a picture of this. So we got picture wise over here. Okay. This way we can draw on it. We like drawing on stuff. There we go. There we go. There we go. There we go. New York. Find the percentile itself. Where's like the 10th percentile? Yeah, we can do that right here. New York. That's awesome. Some upstate New York shout outs right there. She's like, Brian. Who's Brian with a Y? I don't know who that Brian with a Y is. Brian's with a Y. We're at war with them. The Brian's with an I are at wars with the Brian's with the I's. What is the... Oh, no. Let me do something real quick. 2 seconds. I think I need to delete larger files. I've been doing too much. Oh, it's the computer's getting really mad, everyone. Ooh. Everything just... Ooh. Something's going on. This is bad. We had a low memory thing. We got a major... It's... The thing's going haywire right now. Okay, I need to take a second. Let me close out Photoshop. No, I don't want to save changes. 2 seconds. I am in Texas. How low am I on memory? Is it... I have 1 gig left. 2 seconds here, everybody. We had this happen during class where it says out of memory, basically. Let me delete all these. That's going to give me a little bit of space back. What did I download recently that gave me so much? 2 seconds. Oh, I don't want to delete that. Okay, we're almost there. I'll delete this. Okay, let me go to recycling bin. Everything started to go haywire on my screen. Empty recycling bin. Yes. Was I editing videos recently? Okay. Let me look at my space allocation on my computer. Now we have 2.6 gigs. Woo! We doubled the memory. Okay, let's check out the question now. Okay, I don't think it's I got enough RAM. Okay, so here we go. Evan's dropping all my deets right there. So we have a question right here. Below is a pivot table of the average rate paid by a passenger by region. So you can see the region right over here and the passenger's participation in an ACL loyalty program in addition. The passengers in the late seating for dining seating have been filtered out. So if you were to go down here, the dining region is going to go where? Where would they literally say dining region has been what? People saying some Giga Maggies with frogs. The dining region would go where? Where would dining region go? It literally just said that to us. Dining seating, rather. Dinner seating. Well, no, so dinner seating, let me highlight it again. So dinner seating goes where? Dinner seating goes in filter. Does that make sense? It says it's been filtered out. So dinner seating. Now, we've split this apart by two variables, one being region over here. So one of these needs to go in the what, and the other one needs to go in the what. One of those needs to go in the what, and one of those needs to go in the what. Like one of those needs to go in the what, and one of those needs to go in the what. So we've got loyalty program and region. So those are going to go in the what's. Columns and rows, because that's like the separating out right there. So we see loyalty program is already over there. So that means where should region go? Does that make sense right here? Since we know loyalty program is already in the rows, that helps us out right there. This is going to be region right here now. Because they've already helped us out by putting loyalty program here, and region has to be the other one that we're splitting it apart by, and this is what we're filtering by. Now the values is going to be the other thing and the thing that we're displaying. So these values right here are going to be the average rate. And so it's just called rate right here. So the average rate is the values, and we're doing like if it were set to average. So I don't think it wants this specific, but we'd go here rate with the value field setting. So value field setting of average. It doesn't ask that specific, but we could, because usually when you put things in, it's going to have it put in the sum of it. We don't want the sum, we want the average. So the value field setting would be set to average, but this question does want rate right there. Explain briefly one inference from the pivot chart, but be sure your inference has numerical support. So this is just like your interpretations. What do you really notice between the loyalty program members? Like we have the loyalty yes and the loyalty no and the average rate they're paying. What do you notice drastically about this? Like if you go here to the highest here and the lowest here, what do you notice? That the people not in the loyalty program always have what? The people not in the loyalty program versus those in the loyalty program, what? The rates they pay, right? So we could say something like the people not in the loyalty program always pay a higher rate regardless of the region they're in. For comparison, the highest pay rate in the yes loyalty program was Europe, which was $2,280.25, where the European also had the lowest rate in the not loyalty program, but still it's higher. So in all instances, we could quote that number there, 2,316.88. Does that make sense right there to quote the numbers in your interpretations to give numeric backing that the people in the loyalty program are always paying less versus those not in the loyalty program? Do responses like that have a certain amount of senses? I don't think we have any free responses on this test, so that's the good news there. So that's kind of why I did that one a little bit quicker. Good stuff right there. So that's number 14. And now we have percentiles. So people are wondering next, percentiles on the curve. Here we go with the break. Keep dropping those questions in the chat. So we're going to write 2 questions right here, but keep dropping those questions. For assignment 5, could you do an example of 3 and 4A? And that's like Spearman and also what else? Like talking about Spearman. So you want me to explain Spearman? Assignment 5, finding and interpreting Spearman. So that sounds like Spearman because that's the latter part. So interpreting Spearman, I think, right? Understanding how to use Spearman. What is Spearman? You got it, Jackson. Thank you, Jackson, for being here. So Jackson, 1,000 points. Good questions. Keep those questions coming in. I don't know what Devin's talking about. I'm getting this error, no package. So what do we do right there if it says no package? Let's see right here. I'm going to offer 2,000 points. What do we do if something says no package? What do we do? If it says no package, GG easy, what do we do? 2,000 points on the line right here. If anyone knows how to fix no package. Oh, I already dropped it. Install. Wait, it's installed? Double check. Install.packages, GG easy. Make sure it's in quotes. I'll show it here real quick. Ready? Drop those points. So you want to do install.packages and then do in quotes GG easy. So you want to install it, make sure it installs, but make sure it actually installs because it might have crashed on the install. You might have an error when it installs. Does that make sense? There could have been an error when it installed, and then do library GG easy. Now, if it's not auto-completing, it didn't install. So that's one way to know it installed. And you see how I have all these GG packages here. So if it did not auto-complete, it has not installed. Does that make sense, Olivia, right there? Now, the good news is these are not required for the assignment. So don't let this stop you. You're welcome, Muscan, right there. Excellent work. So don't let that stop you if you're working on the assignment, because you can make a histogram by just making a histogram right here and make a histogram like that. Does that make sense? So you can still make histograms. GG makes amazing plots and makes them easier. If you have problems with the install, make sure to message me on Discord. We can join up a video call. We can take a look to see what's going on, because a few people have had problems with there are not installing things, and so we've been fixing those and getting them working. When you type library GG, does it show up right here or not? When you type library GG easy, does it show up? Do you see that right there? Do you see? So this is not required. You don't have to have GG easy to do the assignment. It can do nice things. So you can't use GG easy on the exam. Oh yeah, send me a message. Yeah. So if this does not show up, it did not install. So if it does not show up, it did not install. Let's check out sad times right here. This is R. Programming in R right there, doing a little programming. Okay, let's do some percentiles on the curve. 2 questions coming right up. Here we go. 4A and how to do the univariate. Some univariate analysis. We can do some univariate analysis. You got it. Got it, dude. Here we go. Stat 201, percentiles on the normal curve. Okay. So we'll do one of these with the empirical rule. One with David M. Lane pictures. Okay. So the first one using the empirical rule. What are the numbers for the empirical rule? Cigarette. What are the numbers for the empirical rule? We a lot of times give them to you on the test, but you should know the empirical rule is what? 68, 95, 99.7. Great job, Tara, right there. Great job, Lachey. We throw in all those points during office hours. Keeps just show up, hashtag show up. I want people also to get the points during class, so I try to make sure if you just come to class, you get the points. Last question I'll get. No worries. Do we need anything specific on coding week 6? Remember, check out class yesterday. So watch class yesterday. I did say, like, towards the end, I think, like, make sure you have this and this. If you do the code I'm doing yesterday during class, you'll have everything you need. So that's my best advice right there. So I don't want to say, like, write this, and you get the grade. Check out class yesterday, and if you follow along, you'll get the full grade for coding week 6. Like, the things, yeah, awesome. So you will get the full grade if you did the code we did during class. No, Olivia, 1,000 points. No, good questions. Olivia, keep those questions rolling in. If you did the class we did during, no, have fun. Have a good birthday, Olivia. We got to throw you 5,000. Don't worry. Ask those questions. Ask at all time. Cruz, good to see you here. Dropping in right in time for that 5,000 drop right there. So ask those questions. Oh, some people were saying 99. Some people said 97.5. That's not the number. It's 68, 95, 99.7. There we go. 68, 95, 9.7. Oh, did I miss it? I didn't see it. 68, 95, 99.7. Oh, we did have a few. 68, 95, 99.7. No worries. Good practice. Even I make a mistake. I didn't see it right there. So with this, when we do the empirical rule, we might have a question that says, test scores are normally distributed with a mean of, let's go 75 and a standard deviation of 5. You scored in the 97.5th percentile. What was your grade on the test? Okay. So what is the first thing we usually do when we get a question like this? It says use the empirical rule to solve. Use the empirical rule. What's the first thing we usually do? What's the first thing we usually do right here? Draw it out, right? So we need to identify the mean and standard deviation. There we go. No. There we go. So draw it out. We draw it out right here. And if you're drawing a curve, you could always put your z-scores on the curve to begin and then change the problem. what kind of curve is this called for 1,000 points? When you put z-scores on it, this is called the what curve? This is called the what curve? It's not just a normal curve anymore. It's called a what curve. So what is this called now? It's not just called a what curve. It's not just called the normal curve. It's called the what curve. So what is it called when you put the z-scores underneath it? Standard normal. Jackson, great job right there. The standard normal curve, because it's got the standard on it. So we could add in the values we're doing right here for the problem below it, and this is going to help us get the answer. Does anyone know the answer to this question right now? See if you can get the answer. Then we're going to do a David M. Lane one next. Close, not 90. Lachey, good guess right there. Natalie, that is correct. And we got to throw 1,000 points for those guesses and those right answers. Remember, we're here to practice, so getting it right or wrong, Rock knows.
It doesn't matter.
It's all about that practice. So when you do percentiles on the curve, the 97.5th percentile should be where? On the right or the left side? The 97.5th percentile should be on the right or the left side. Where would the 97.5th percentile be? When you hear percentiles on the curve, the 97.5th percentile is on the right side, because that means 97.5% of the data is where to this point. 97.5% of the data is where to that point. 97.5% of the data is where to that point. Is below, right? So that means below. So it's actually right there. Now, why is it right there? Well, if 95% is between -2 and 2, then what percent is total outside? So I want the outside total. So if 95% is between, what's total outside? What is total outside? Total outside is what? 5 total. So then we cut it in half and we get 2.5 right here. And so with that, we can deduce if 2.5% is above here, what does that mean? If 2.5% is above here, what does that mean? Because now we can make a deduction. If 2.5% is above that point, then what does that mean? And percentile means how far you are on the curve to the right, but once again, it's the area below. So higher percentiles are on the right, but I don't want people to think it's to the right. Percentile means the area below. So 97.5 is below. So the answer to this question on the test would be what? What was your grade on the test? So the answer to this question would be what? You got 84? It might, if you do it on an applet, it might be like 84.8 or something like that. If you do it on an applet, and great job right there. Wow, lots of answers. Love it. Love all those answers in the chat. The answer to the question would be 85. So if we do it on an applet, we'll get a slightly more exact answer. We're going to do a similar problem right here with David M. Lane, but with pictures. So use the picture to solve. Okay, so now we're doing a similar problem. And this time it's asking... So it's asking the 80th percentile. You won't use it on the exam. You'll use the pictures. So you need to know how to read the David M. Lane pictures. Can you do another percentile? So, and we could go back. Let's do another version of this here. We'll do another version. So this is going to use the percentiles from a picture right here from the David M. Lane. Does that make sense, Evan? Let me know, everyone, if you have any issues. There's the David M. Lane picture right there. All right, so let's go and take a David M. Lane picture. So we'll go right here. And we will do the following and do the following. All right, so I'm doing it a bit of a different way today to see if you understand all the pictures and know how to solve this. Okay. So, there we go. What did you score? What did you score? Does anyone have a guess? Could anyone guess right now looking at this? Just take a guess. Does anyone have a decent guess? Go down here and look at this. There we go. Okay. Does anyone have a decent guess? I have a pretty good guess. I'll tell you my guess in a second right here. Does anyone have a guess? What would you guess? So we want to know where the 80th percentile is at. That's all right. This is just our practice to understand what the curve's showing it. McKenna, thank you so much for saying that. That's all right. We can say no. We can be like, I don't have a guess. Does anyone have a guess? And how'd you get that guess? So if we draw on this curve, it might help us out a little bit here. Decent guess, Jackson. Decent guess right there. So think about, we could actually use our previous curve to help us out too. Victoria, excellent guess right there. Victoria, very good. I'm guessing Victoria earned everyone 1,000 points right there. I'm guessing 84. These are the hardest ones. Good. This is the good practice right here. I'm guessing 84.16. That's my guess. 84.16. Jackson might have it exactly. I think it's a little high. So let's see. What do you see visually on the screen? I guess I should have shown you that. What do you currently see visually? What is currently shaded for you here visually? What do you see? Explain to me what you see right here. Like, what is that? What do you see? Not quite middle 50. Middle, good answers right there. Middle 60%. Does that make sense? So that's the middle 60. That's the middle 60%, right? That's the middle 60. So if that's the middle 60, what is this? And what is this? What are those areas right there? If that's the middle 60, what are those areas? If that's the middle 60, what are those? 20 each. Does everyone make sense? 60. Great job, Muskin, right there. So we would say 20 and 20 right here. There we go. So now that we know this is 20 and 20, what does the 80th percentile mean? What does the 80th percentile mean? Like, to talk about the 80th percentile means what here? What does it mean to say we're at the 80th percentile? Why would it be 20? Because we have 60 in the middle. Total outside is 40, and 40 divided by 2 is 20 because of the symmetry. Does that make sense, Ivana, right there? Let me know if that makes sense, Ivana, because there's 60 in the middle, 40 outside, 20 on either side. Is everyone following that right there? Good, Ivana, thank you for asking 1,000 points. Keep dropping those questions. Why is it this? And then hopefully if I draw a little bit more, it'll help out with seeing it. So I think people are identifying that if we're talking about the 80th percentile, we're saying that what? Right here. What does it mean that that is the 80th percentile? What does it mean that that is the 80th percentile? You're on the right track, Evan. Oh my gosh. Evan, I can't math. Evan, we got to throw 5,000 points because Evan, it's going to be closer to 79.18. My number was off. I used the wrong mean. I've been doing a lot with mean of 80, and my answer was wrong. Evan earning everyone 5,000 points with a better guess right there and seeing it. And I looked at Evan's number and I was like, wait a minute. And I was like, oh, whoops. So Brian did it wrong. And Evan's noticing now, and Evan's starting to get the solve right there. So good notice, Evan. I did, my guess was off. So sometimes we make a wrong guess and we're like, wait a minute. Oh, wait. Because you know what would really help us see where the answer's at? Do you know what would really help us see where the answer's at? What could we do to really help ourselves and see where the answer's at, where that answer's going to be close to? What could we really do to this curve to be like, oh, it's probably... What could we do? What could we do down here? Write the mean and the standard deviation of the problem. So the mean of the curve is 75 and the standard deviation units are 5. So if we put down here 75 at the center, we see 80, and we know the answer to this is somewhere here. Does that make sense when we do this right here? Wait, why is it 6% in the area and this is the 80th percentile? Because remember, the 80th percentile means what right here? What does it mean to say this is the 80th percentile? That's the middle 60, but this being where the 80th percentile is at means at this point right here. What does that mean? At that point right there. And great job right there, McKenna helping out. 1,000 points, McKenna. Keep those answers coming in. What does it mean that it's the 80th percentile? At that point on that line, what? What does that? And so that means at that line right here, what? On this line, there's what? 80% of the data is below it. So McKenna was doing it right there. 80%. It's not, and it's weird because this is very close to 80, so the problem is a little confusing in that sense. But the 80th percentile means 80% of the data is below this line right here. That's what the 80th percentile. This down here means one standard deviation above the mean is a what? Does that make sense? This point right here is not where the 80th percentile is at. Excuse me, whoops, went away. This is the 80th percentile right here, that little thing I've marked. This right here means one standard deviation above the mean is an 80. Does that make sense? A little confusing because there's two 80s on the screen, meaning the 80th percentile is right here, and this is one standard deviation above the mean is 80. So with that, the answer is right here. What do we know currently about the 80th percentile? What do we know currently about the 80th percentile? Great job, everyone, reviewing and practicing. What do we know currently about the 80th percentile? What do we know currently about the 80th percentile? Here, I'll give you a hint by highlighting it. We currently know what about the 80th percentile? What do we currently know? What is that? We currently know it's what? We currently know the 80th percentiles. Well, that's the answer. Tara, great job right there. It's 0.842 standard deviations above the mean, so we know it's z-score. And I think Blake's solving it out right now. We know it's z-score. Does that make sense? So the answer to this question is 0.842 standard deviations above the mean. It should be a little bit less than what, which Blake got right there. When you see the answer visually and you're finding it, the answer should be, because here's this, the answer is going to be a little bit less than what? The answer is going to be a little bit less than what? When you see this here visually, the answer is going to be a little bit less than what? Like you'd be like, whatever I find needs to be, because the highlighted thing is the answer, it needs to be a little bit less than 80. So when we solve for the answer, we should be thinking, okay, I'm going to get a little bit less than 80. And remember, if we take the z-score right here, we can go to the mean and add to it that many standard deviations, the z-score times the standard deviation. So we take the z-score right here, times it by the standard deviation to put it back into units of the problem, and add it back here to the mean right there, and we would get 75, which is the mean, plus the z-score of 0.842 times the standard deviation of 5, and I'll trust Blake right there, who said it's 79.21. And how close was I? I was just off by a fraction of a decimal right there with my guess. So let's do another virtually identical problem to this. How would you find the z-score? We would give it to you. We would give it to you. So I could, using from memory, give you a problem. So here is a pretty much identical problem with a z-score given to you from memory. So now we are going to say you scored in the top 1% of class. The z-score for the first percentile is negative 2.3263. What is your score on the test? Okay, so this is without the picture, but giving you the z-score. So all the picture really does right here is give you the z-score. So if I were to say the z-score for the first percentile is this right here, do you see how it's negative 2.3263? So I could give you the picture. I think people are saying so. You will have to find like the answer to what did you score or something like that. So these are really good example test questions right here. We could give you the picture. We could tell you the z-score. So does everyone see how this right now, I'm going to make it a little bit smaller. Does it make sense how this is the same information? I'm showing you currently the first percentile right here. Why is this the first percentile? So wait, remember, you're in the top 1%. Good answers right there, Lindsay. And we're going to see how to solve this here in a second. You're in the top 1%. So does everyone understand why is this the first percentile right now? Like, why am I showing you the first percentile? Tara, I think that's right. And great job right there, Evan and Tara, solving it. Why is that the first percentile? Which you wouldn't want to be in the first percentile. You want to be in the 99th. This is the first percentile. Why? Why is that showing you the first percentile right there? Because at this point, At that point, and great job, we got to throw Tara and everyone 1,000 points. At this point right here, 1% of the data is below it. Does that make sense conceptually? At that point, at that spot, 1% of the data is below it. And why is that a z-score? Why is this visually right here showing you a z-score? Because the curve has a what of what and a what of what. So why is this currently a z-score? How do you know that that is a z-score right there? How do you know that that is a z-score? And great job, Cruz, finding out how to do the next part of the solve. And so Cruz is pointing out, well, you could just flip the sign on it to find the top 1%. And the top 1% is going to be the 99th percentile. Great job, Cruz, right there. Does that make sense? So it would just be on the other side of the curve. So we just flip the curve. So we can do this if we have the applet open, which we won't have for the test, but we can just show it over here that it is just the positive version. So now that we know the z-score, finish my sentence. We know the answer to our question is blank blanks blank to the blank. Like if you know the z-score, so a lot of times people say, well, what's the formula to solve? It's like, well, the z-score is telling you that your answer to the question for the 99th percentile is blank blanks blank to the blank. What does the z-score mean? Because it's a measurement of distance of this from the this. The answer to our question will be 2.326 standard deviations, and this time above the mean because we're going to the 99th percentile, right? So 2.326 standard deviations above the mean. So now we just think about writing this. Since we know the answer to the question is over here on the other side of the curve and won't have the negative on it anymore, the answer is going to be right over here. We can even check by putting back the context. And I think you said it's something close to like 86 or so. Does everyone see how I'm able to, was it like 86 point something? Is that right for those who said 86 point something? We're able to take an educated guess by looking at the other side of the curve and say, about 86, maybe 85, 86, 86.6 right there. So it's got to be 86 point something. Great job, Tara. And we can see this visually right here. Like drawing it out a little bit, you'll be like, it's about 86 point something right there. And so now, so I probably need to move that a little bit over. How do I keep changing the mouse speed? I need to lock that. Boop. There we go. And yeah, you can ask questions. You can message me on Discord, ask questions about it. So the answer to the question, we go to the mean, 75 plus, or mean plus z times standard deviation equals observation, 86 point, and 75 plus the z-score of 2.3263, it's got the extra decimal, and times the 5 right there. Solve that out, and you will find the observation of 86.63 is what you scored when you were in the 99th percentile on the test. How's that doing right there? Yeah, these just come down to practice, like understanding how to read the applet pictures, knowing how to do it. Let's do one more percentile one, and then we'll do a little 320. I'm going to try to do crossover ideas. Finally getting it nice. It really is just practice. That's why I say chapter 5 is all about that practice. What was the question asking for? You scored in the top 1% of the class. I guess I should have said, yeah, what is your score on the test? So you scored in the top 1%. If you feel like it counted you off, just let me know. Usually you're fine if it says report to 2 decimals, report to 2 decimals. If it doesn't say report to 2 decimals, just put in what you find, like whatever in the calculator. Usually we don't take off points for putting in more decimals, but just put in, if it says 2 decimals, 2 decimals. If it says percent, do percent. And if you feel like the test counted you off unfairly, just let me know. Okay, so let's do one more of these, then we're going to hop over to do some 320. But while we're doing 320, don't leave, because I'm going to do some crossover with 201 with the 320 ideas. So the 320 ideas do cross over to 201. So if you're studying for the test, we can still do some ideas for 201 doing 320. So the test scores are normally distributed. Let's ask the following. This is another curve one. We were doing these during morning office hours. So check out morning office hours if you want some review too. Not review too, but review also. And let's say the following. Okay, so we're going to keep the same mean and standard deviation so we don't have to really change the curve much, but I'm not going to show you the answer down here. I'm going to say, what percent of students would you expect to score between a 75 and 95 and 85? So this one should be pretty quick right here. This one should be pretty quick if you know how to do this using only the empirical rule. What percent of students would you expect to score between a 75 and an 85? Should be pretty quick if you know how to do it. Now, the picture is going to help out a ton. So what do? The thing is like, I can draw this out. I can draw it out a ton of times. I don't have the answer yet. Draw it out. Draw it out. Try drawing it out. Let's take 30 seconds right now. I want everyone to draw it out, and then I want people to confirm an answer. Ready? I'm not going to say the answer yet. Take your time and draw it out. I'll show you the answer. Take your time and draw it out. So draw it out. Here's the mean. There's the standard deviation. Draw it out. So draw it out. We're taking 30 seconds here for people to draw it out. Once I show you the answer, you'll be like, oh, that's obvious. That's why you gotta draw it out every time. Like, have a little drawing, be like, that's the thing. Someone's got the answer already. We had some updates on the answers after people drew it out, I think. It's about the 30 seconds mark right here. Oh, I didn't click 30-second timer. Like, it should be 30 seconds. I'd like to time that to see if I found it. Good. He said someone, which is not plural. It might have been the chat sometimes delays. Okay. So let's look at this right here and see how to draw it out. We have between 75 and 80. 85, excuse me. Now, what do you notice about this right here? There's a pretty quick solve right here, I would say. And Natalie's got it just instantaneous right there. Natalie solved it super quick. Natalie said, wait a minute. That area right there is half of 95. That's probably one of your quickest solves right there. I saw Blake also did the solve of adding these two numbers. If you know the breakdown of the curve, you can break down the areas between to 2.35. And so if you know those numbers, you could break down and add up these two numbers and still get 47.5. So drawing this out right here, this area we are concerned about in this region is going to be 47.5. So that's really good right there. Let's change the question slightly. And if you've already solved this one, you can do a quick solve on this next one. Let's do between 70 and 85. So this is just have it drawn out. This is if you've already done this one, this will be an even quicker solve right here. But between 70 and 85. So draw it out. Try doing it right here. Have the curve drawn out. Draw out your curve. Cut down the areas. Use the empirical rule to solve. And between 70 and 85, what would that be? These are only empirical runs. They wouldn't give you a graphic. They would just say use the empirical rule to solve. Blake just got it right there. Boom, Blake. So what did you do? Blake, did you solve it the way I would probably solve it if you already have the previous answer? If you look at, and I think Blake's and Tara, great job there, Tara, too. Tara has it broken down, I believe. So a few different solves right here on this problem now. Because if you notice, now we're going over to here. We already know that this blue area is 47.5. We just found that out because that was half of 95. And then Blake did what I was thinking kind of as the quickest solve is to go right here. And Blake, how would you know without memorizing that this is 34 between 0 and 1? How would you know that this area right here is 34? How would someone solve that if they're like, wait, how are you solving that this is 34% of the solving and that's a hint right there. Half of 68. So that's how we're getting 34 right here. It takes a little longer to break down the curve further, but now that we know that this is 34, we could just add these two numbers and get the total area between these margins. Great job, Mackenzie and Lindsay right there. So now we know the answer is 81.5, which is people are showing in the chat. Also, Tara, great solve there too. Got to give 1,000 points to Tara. Tara, amazing work in class and in office hours. Great job. Tara went and added up this area right here, which is 68, and then added to it, or I should show this with different colors right here. Tara went and added this, and then added this in here. So the addition was, it's going to get you the same answers, but the mathematical adding was 68, which is the area between here and here. And then the remaining area over here is 13.5, and you confirm the same answer. So just being able to solve this a few ways or break down the curve, you can just understand and get the answer correct with the empirical rule, just if you practiced it a lot. But yeah. And why do we have the empirical rule and why do we have the applet? Write me a question. Someone tell me a mean and standard deviation right now. Tell me a mean and standard deviation. This is my last little bit, then we're going to do a little 320, but stay if you're 201 because it's going to be correlated with your, I don't know, associated with your class. Give me a mean and standard deviation. Random mean, random standard deviation. 665. Ooh, you're getting some crazy stuff. We got like some production stuff right here. Give me a percentile on the curve. Give me a percentile on the curve. Give me a percentile. Ooh, Victoria giving it a notation. I got to write that down. Give me a percentile on the curve. The 56, that's so mean. That's so mean. The 56 is so close to the center. That's a super tough percentile. So we have the 56th percentile. We have the 76th. I'm going to cheat and do 75th. Someone said 75th also. We have 88th percentile right here. Okay. All these numbers must do what as you go up the curve? What do you notice immediately about all these numbers as you go up the curve? No worries, Tara. This is a really tough one. All these numbers must do what as you go up the curve right here? They must rise. Does that make sense? Like, as you go up the curve on percentiles, this is how Brian solves it and why my knowledge of the curve can help me solve these questions. And so I know the 56th percentile is actually going to be kind of close to the mean right there of 665. It's going to be within the first standard deviation right there. That's not 0. We're just going to put the z-scores below here, which is 1, 2, and 3. And so the 56th percentile is going to be very close. It's going to be like 8 higher. So my guess for that is going to be, let's go 6. These are my guesses. 673. The 75th percentile, I actually know the z-score for that. It's 0.673. So you can actually take a third or 2/3 of the standard deviation. So 2/3 of the standard deviation is about 23 rounding up. So 23 plus 665 is, let's go right here. This answer is going to be 688. My fingers already did that. They know the answer. And the 88th percentile is going to be close to the 90th percentile, but it's going to be a little bit below. The 90th percentile has a z-score close to 1.28. So it's a little bit below that. So about 1.2-ish. And 1.2, I need to take 20% of that. So that's an extra 7. So that's 41. So we'd go right here and we go 41 plus it. So 706. Okay, so these are my answers. These are my answers right here. Now, the first one's the toughest one. What could I go and do to find the exact answers to these questions? What could I use to find the exact answers to these questions? That was my knowledge that I carry with me at all times using things like the empirical rule. So that's why I know the empirical rule, because I can use my knowledge to take some good educated guesses of how the curve works. So when we're doing percentile, we always do area below. Now we can actually put in the context of the curve to do things like 665 and 34. So the first number right here, to accurately find the right answer, the first number, hopefully we're right on these, 0.056 is the toughest one. And we were kind of close. We were off by 3. I think the other ones are going to be even closer, but I said 673, it's 670. Does that make sense? Pretty close right there. Like, close. Now, the next one is the one I'm really excited about. How much am I off on that one? I said it'd be 688. How much am I off? I didn't use the applet. I just used my knowledge of the curve to get that answer. Boom. Down to the 6.067. Too much. Blake's like, you got to do better. Hopefully the 706. That one, because I know the z-score. I've done these problems a lot. It's 0.063, 0.0673. I said 0.0673. I think it's 0.06736. So I was off by the fraction of an amount. So I was able to basically know the answer to that without even using the applet. I'm like, well, I know the z-score, so boom, I know it. And so now we have the last one, which I probably did all right on. 88's a little tougher. It's 705. I said it's 706. It rounds to 705. How did you know the z-score? We use them later for confidence intervals. So I know a lot of z-scores for just different things like the middle 50%, the middle 80, the middle 90, 95, 99, 98. There's a lot of common z-scores like 1.2816, 2.5758, 2.3263. So I know the z-scores for the following. I know it for 50%. 50% is 0.674, it'll say. And then we're going to switch topics here. The next z-score I know is 80% confidence, 1.2816. It rounds up. The next one I know is 90%, 1.96 classic, basically 2. The next one I know, 90. Oh my gosh, 95 is 1.96. 90 is 1.6449. Extra decimals on that. 98 is 2.3263. And then the next one is 2.5758 right there. And it rounds. But you don't need to know those things. It's just if you teach the class for a long time, you start to know these things. But I asked you, you forgot the period? Oh, no. Oh, did I? If I asked you the z-score for the middle 68%, what would you say? So think about what you know. If I ask you the z-score for the middle 68%, what would you say? If I ask you the z-score for the middle 68%, what would you say? You would say 1. So if I ask you for the 84th percentile, what would be your answer? Think about how you can also solve some of these. So this is what you know now. If I asked you for the 84th percentile, what would you say as your answer? We're bringing it back to your knowledge now. What would you say is the 84th percentile? And I've put it so you have to make sure your answer is contained within mine. Do you see how I've put them in order? So see if you can find your answer for what is the 84th percentile on this curve. Remember, your answer is going to be between the numbers I gave right there. This, if you understand at this level, this is the highest level of understanding, I would say. Sometimes I teach at all the different levels, from the beginning understanding to the upper understanding. If you get this, you're like, oh, okay. Well, you know that. So what's the answer? What would it be? Close. I want exact, though. I want exact. I want a really good guess. Those are good guesses. I think those are guesses right there, right? Don't you know the z-score for it? That's what I was looking for right there, Blake. So what did Blake do? What if you look at Blake's answer of 699 is what? Blake's answer of 699, when we put the values in here, Blake's answer of 699, look at that, just by 0.2 off, is 1 standard deviation, because there's only 16% above the curve right there. That makes that mark right there the 84th percentile. So you were able to figure it out. Blake used David M. Lane. But do you see how I'm kind of using this knowledge right here that we have and doing similar things to find these things out? I just know more numbers. Like the empirical rule is memorizing 3 numbers, but I've memorized like 6 or 7 spots on the curve. Does that make sense how I'm using just more spots on the curve to narrow down my answer? Because I know like the 50, the 80, the 90, the 95, the 98, the 99. So that's why when people give numbers inside of here, it's really hard for me to give those answers, because the curve especially so dramatically changes in the middle percentages. Great job right there, Lindsay. Yeah. Oh, well, the 34 is ironically not from the breakdown of the 68. It's a standard deviation right there. I know more numbers. Well, I'd hope I do. I've been teaching this for over a decade, so I'd hope I know it. I'll let the man flex right there. Just, boom, I need to work out more. No, that's a weak flex. I wish I knew more numbers. No worries. You don't need to know it for the test. It's just the practice. It's just the practice right there. Just the practice. We'll get Greg Doucette on here. He'll do some flexing for us. So with this, let's head over to a little 320, but don't leave it for 201. It'll apply. So guess what topics... Benches 475. I wish I did. I bench 135. I bench like, I don't know. Bench like 210 maybe. I could probably do 210. Like, I don't know. Maxing is a little bit interesting. We're going to do some assignment 5. Spearman. Oops. BS 320. Assignment 5. And if you're here for 320, I benched 10 on each side. That's cool. My brother did that in high school. Shout outs to everyone. Weak or strong, it doesn't matter.
It doesn't matter.
Only matters is if you're having a good time. You're happy. So, assignment 5, Spearman and Pearson output. That's a joke? Jokes? The joke? What joke? Let's go over here and head to the main screen. Let's do it. Okay. So, what topic are we doing in 320 right now? Well, we're doing regression. But also, we're doing correlation. We're going to add this. Me benching town Seattle. We're doing correlation. Why is correlation important to 201 also? Why is correlation important to 201 also? Why is correlation important to 201 also? Why is correlation important to 201? Have fun, Evan. Have fun at the meeting. If you're 201, why is correlation still important to you? Why is correlation still important to you? I'll give you 1,000 points. Correlation does not mean causation. That is true. We never like to say those quasi words. So why is correlation still important to you as a 201 student? Well, it tells you how variables are related to each other, and it's also on your test. I guess, no, that's important. Great job, Victoria, there also. So correlation is the relationship between a quantitative X and a quantitative Y. Good enough. Nice job right there, Evan. Correlation is the relationship between a quantitative X and quantitative Y, and we can see it over here. And if we do the correlation between two variables, let's pull up the MT cars data frame. So we've loaded up a data frame of cars right over here. Let me erase everything over here. Really? I don't usually click that button. So here's the MT cars data frame. This is just a bunch of cars. If you're a car person, you probably know it looks just like Excel. And we have the relationship between two quantitative variables. So all of this is very ripe for correlation. What do you think would happen to the miles per gallon a car gets when it's heavier? Just tell me what kind of relationship you expect when a car has higher miles per gallon, a higher weight. If a car weighs more, what would you expect? So if we were to predict the miles per gallon of a car from its weight, what would you expect right there? Like cars that weigh more, generally what? If we're predicting the miles per gallon, what would you expect? What would you expect? I'm showing how to do the question of the applet experiment. You will do the pictures. Taylor, check it out. If you hear me, Taylor, check out the questions we were just doing. And we did a lot of example questions with applet pictures. So if you check out all the questions we were doing right here where we showed applet pictures, we were showing some applet pictures and how to solve them like example questions, Taylor. Good questions, Taylor. Let me know if you want to do more. We have right here. So cars that weigh more, we would probably expect to, and here's the graphic, cars that weigh more, here's when the weight goes up. Cars that weigh more might have what miles per gallon? Cars that weigh more probably get what miles per gallon? Cars that weigh more, and this is a scatter plot right here, cars that weigh more, we would expect to have what miles per gallon? When a car weighs more, we would expect its miles per gallon to be what? If a car weighs more. If a car weighs more, lower. Great job, Lachey, right there. So when we do correlation, we want correlation to be what conditions? What are our conditions for correlation? Like if this is proper correlation, we need to have what right here? What kind of relationship should these variables have? Like what are the conditions? Like QQ, which means it's a scatter plot. What are the conditions? So we'd have to look at this and see, is it proper to do correlation right here? So we'd have to look at it and say, like, can we do correlation? And those are border histograms right there, which are univariate displays. So what do we have to do right here? What are our conditions? Here is one condition. Here is two condition. And there is three condition. The first condition is what? To do correlation to start. Ooh, actually, you know what? I might notice. Maybe. I'm noticing something. The conditions are two quantitative variables, which I call QQ, or quantitative variables in the notes. It's called quantitative variables. I call it QQ. So both of these variables right here on the ends of it, on the X and the Y, need to be two quantitative variables to do correlation, QQ. And then what am I questioning about the relationship between these variables? What am I questioning? I've got the second condition right there, QQ, something, something. No, these. I'm questioning the what of the relationship right there. I'm questioning. So this is all 201 right now, straight enough. So it's negative and curved, right? And then it looks like it has no outliers. That's the yellow. I'm putting checks right there to be like, yeah, it looks like it's got no outliers. So does everyone see why I'm thinking, is this straight enough? Now, correlation only applies to linear relationships. But if you're in 320, we don't just have what is called Pearson correlation. We also have what is called what correlation? Do you see it? Here's your correlation in 201. You said there is a negative, maybe somewhat linear correlation. We don't just have Pearson correlation, which is Pearson's R, the one you learned. We also have what is called Spearman rank correlation in 320, which gives all the numbers ranks. Really quickly to show how that's done mathematically is if you had a relationship right here between an x and a y variable that went something like this, this would have perfect rank correlation. You go to your x's and you rank them in order from lowest to highest. You go to your y's and rank them from lowest to highest. And the ranks are now what? Perfectly whatted. Do you see the ranks? The scale of the numbers doesn't matter anymore. This could all be on from 0 to 100, and those are the original values, but I'm ranking them. That's what it means to have rank correlation. So do you notice the correlation between the ranks is what right here? So we might have correlation, original correlation of linear correlation. The linear relationship might not be as good. The linear might be something like this. Might have an R value of 0.8. But the Spearman rank correlation, which is its true relationship, the Spearman rank, so correlation of the rank, Spearman, is 1. Spearman rank correlation. So the Spearman rank correlation can be used for nonlinear correlations. Does that make sense? That's 320 talk. That's not on 201 tonight. So if you're 201, you can just tune out for that. But there's ways to handle the nonlinearity. So it turns the values into their ranks, no longer their original values. So when you see that this relationship we have in the data appears to have a bit of nonlinearity, you would say, maybe I should use what instead of Pearson? Due to the nonlinearity, maybe I should use what? So if we have issues like nonlinearity, or we have heteroscedasticity or plot thickening. So let's say plot thickening. Or outliers, if there's these issues. What would we use instead of Pearson? What would we use instead of Pearson? Instead of Pearson, if there's issues, what would we use? My hair is all crazy. Instead of Pearson, what would we use? What would we use? We would use Spearman. So Spearman has one condition, though. It is required that the relationship be your favorite band. Requirement of Spearman. The requirement of Spearman is that you must have a relationship that is monotonic. Monotonic means goes in one direction. So this is monotonic because it constantly goes up. Mono meaning one, tonic meaning direction. So you could have monotonic down and that'd be fine too. So it could go like this right here and just weave a little bit and go down. This would be monotonic still because it just goes in one direction. When are things non-monotonic? Non-monotonic means it doesn't just go in one direction. So a non-monotonic relationship would be something that goes up, then goes down. It's automatically non-monotonic now. It could go back up again, but this is a non-monotonic relationship. As soon as you see a change in direction that becomes slightly apparent, you might say, oh, it might be going down there. I don't think it is. If you see something right here, probably at about that point is when it's not monotonic anymore. So we see that it probably has changed direction and there's a different relationship that is going to be non-monotonic. So monotonic meaning one direction, non-monotonic meaning not one direction. What other questions are there? Who's got questions in the chat? 320, what other questions do you have about this? What are you wondering? We did some univariate in class. Let me know. This is identifying whether to use Spearman or Pearson. What other questions do we have as people prepare? What other test questions? Let's go to the main screen. What are people wondering about? What are you wondering about? What questions do you have? Lots of review. It's interesting. I don't know if you've ever done the test on the fall break day, like the day before fall break. Good work, everybody. Oh, no one's in the chat right now. Maybe everyone's studying. A lot of people answer our little survey. 124. Might go and answer some emails. All the emails. Can you go through some Can you go through some chapter 6 and maybe expanding on why some of the chapter 1 terms are what they are? Which chapter 1 terms? So chapter 6 review. Which ones do you want to work through? Want to work through 5 on the practice exam? Sure, 5 on practice exam. Chapter 6 review. Practice exam. Let's do practice exam number 5 first. And then, because we just did some chapter 6, let's do practice exam number 5. We can knock that one out real quick. Okay, practice exam number 5. Let's do that, and then we'll do chapter 6 review. Okay. Let's see. This is Z-score stuff. 10140. Here we go. Let's do practice exam. Just like, oh, histogram box plots, what makes them categorical and quantitative? Good stuff right there, Blake. Okay. So here's the number 5 on the practice exam. And let's see what we got. If you're looking for any extra practice exam questions, there is a playlist found under Review 1. Check that out. Maybe I didn't cover one you're looking for. There is the playlist where I walk through these and explain them, but we want to also work them here. A particular brand of cell phone is normally distributed. That means we're seeing the normal curve. So automatically at this point, we want to start doing some notation and write capital N and start putting in the mean and standard deviation. So we see a mean of this, which is going to be the mean, and a standard deviation of this, which is going to be the standard deviation. So 2.5 and 0.32. There we go. Univariate analysis, please. We can do some univariate. Talk about that's going to cross over to Blake's right there. BS 320, assignment 5. Univariate analysis. What does that mean to do univariate analysis? You can use a TI-84 Plus on the exam. That is correct. Calculate the Z-score of a battery that lasted 2 years. So what is the notation for a battery lasting 2 years? Does anyone know the notation of this? If a battery lasted 2 years, what would be the notation for that battery? Like it lasted 2 years, we'd call that its what value? I'll start writing the notation for the Z-score formula over here, and you might be able to identify the missing component. So what we wrote up there was mean and standard deviation. So what is observation minus mean over standard deviation? So we have right here the mean. We'll plug in the standard deviation, and that is the value of y. So notation really helps if you write down the formulas right here. We don't give the Z-score formula, but it's observation minus mean over standard deviation. So we take 2 minus from it to 2.5, which is the mean. Once again, we're taking these values. I'm highlighting them to show which values I'm taking. And then we divide by the standard deviation right here, which is 0.32. And we should get something close to a Z-score of negative. Shouldn't be that far away. Shouldn't be that. You might have done 25 or something. So 2 minus 2.5 divided by 0.32, negative 1.56 right there. Negative 1.56 will work. There we go. No worries. Just check. Always check your math. Always check your math, and then be like, is that 6 standard deviations below the mean? So what percent of batteries can be expected to last 2 years or more? So 2 years or more, and it wants you to give an interval right here using the empirical rule. So this is an empirical rule question asking you to give an interval. Now, we just found the what for this. What did we just find for this? I just found the what for 2-year batteries. I just found the what's for this. So what did I just find right here? I just found its what? I just found its Z-score. So now that we know its Z-score, I can go down here on the normal curve and mark where its Z-score is at. So the Z-score is negative 1.56. This is from the previous problem right here. So make sure to take and mark right here. That is the Z-score of negative 1.56. Z-score of negative 1.56 right there. So now it wants to know the percent of batteries that last 2 years or more. Remember, we already know its Z-score right there. And so with this, I'm asking for the area where to this? to the right or to the left? I'm asking for the area where. I'm asking to the area where, to the right or to the left? What would it be, to the right or to the left? 2 years or more. This would be the area to the... Two years or more. To the right. And it might help if we put the numbers below. No worries right there, to the right. Because 2 years or more is going to be above this. Let's throw 1,000 points. Don't worry if you get it wrong. It might help if I put the context numbers below, where we put 2.5, because that's the mean. And then this would be 2.18. And then this would be 1. Was the standard deviation is 32, so 1.86. Yeah. How am I getting those numbers down here? How did I obtain these numbers right here? So I know that 2 is right here. How am I obtaining these numbers down there on the bottom of the curve? How did I get those numbers down here? Why did I get those numbers? At the center of the curve is the what? Yep, same color. At the center of the curve is the what? The mean. Great job, Lindsay, right there. And then we go down standard deviations. So each time I go down, I'm going down that 0.32 right there, going down each time by subtracting that off the curve. So we see right here that right here would be where 2 is at. And so wouldn't batteries that last 2 years or longer be above? Does that make sense that this is the answer or the visualization of what we're looking for? That is batteries that last 2 years or longer. Like at the center is the mean of 2.5. So this is the answer we are looking for right here. How are people doing with this right here? Does that make sense? Does everyone follow this? That is the exact answer. But the question itself gives 2 blanks because it wants between this and between this using the empirical rule numbers. So the answers we can get would be for the area, we'll zoom in a little bit here. The area we can get on this would be on the empirical rule numbers, we could go and say this area or this area. Does that make sense, just visually speaking, to say if we use the empirical rule numbers, we can go right here and give those 2 answers to say it must be between these numbers, i.e. it must be more than from here over, but less than from here over. It's somewhere between more than that, because if you went from here over, that'd be too little, but it has to be less than this, because if you went from here over, this would be too much. So this is the too much. So the question is, how much area is from right here over? Does anyone know the answer to this? How much area would be from this spot right here over to the right? How much area would that be? Does anyone know it pretty quickly? If we've been doing a lot of these today. Does anyone know that pretty quickly? How much area would be from this line all the way to the right? How much area would that be? If you know it, we'll show it here in a second, but here's some tricks. $97.5. 97.5. So the middle 95% would be between here and here, but then you need to add to it. Does it make sense that we would have to add to it the remaining 2.5 over here? Does that make sense conceptually to everybody? You would have to go across that, and we're asking about the area from this line to the right. So we're going all the way over. So you're asking all the area right there. Next, we want to find the other area right here. It's the 2.5th percentile, so 97.5% would be above it. And now we're asking about this line right here. Now, if you know the percentile, you can actually figure out the area above it pretty quickly. So we're asking about this area to the right of this. So it'd probably be easiest to find the area to the left of that and subtract from 100. Well, inside of here is the middle 68%. and then outside is the 16. So how much is this total right here? So the first answer was 97.5, and the next answer is what? 84. Yep. There it is. That's one of the tougher problems right there. Really good practice if you can solve things like that, because you have to get 2 solves on it. So good practice problem right there. Good practice problem. And I think we had, was it, let me do the next thing right here. Next thing. Next problem. Chapter 6 review right here. Okay, let's do a little Chapter 6 review. Ooh, so tired. Chapter 6 review. Let's do it. No, Ivana, it's a tough question. It's a tough one. Good work right there, Ivana. Keep it up. Tough questions. We're here to work all the tough questions. We're here to practice. When it comes to correlation has what characteristics? Correlation has what characteristics? There's a practice test over there. Correlation has what characteristics? What are the characteristics about correlation? What does correlation tell us? Thank you, Blake, for that positivity right there. What does correlation tell us? What does correlation tell us? Does it tell us anything? What's the point of strength, direction, form, unusual features? Yep. Strength tells us strength. Direction, form, unusual features. Tells us those things right there. Strength, direction, form, unusual features. Strength, direction, forms, unusual features. So strength, if we measure it with correlation, only measures what? Strength with correlation only measures what? When you measure strength with correlation, like the value of R, it's only this strength. It measures the density of points around the form, correct. The value of R, great job right there, Blake. The value of R is going to be only linear strength, is for linear strength. This does not mean there is no relationship if R is 0. So when you have right here, R is linear strength, you can have 2 examples right here. Data 1. How would you describe relationship 1 right there? Relationship 1. Relationship 1 is what? Relationship 1 is what? Relationship 1 is a weak, non-existent relationship between weak, non-existent, because correlation equals 0, so there is no correlation. And great job, Nicholas, right there. It's weak, non-existent, no relationship in the data points. But relationship 2 only has correlation equal to 0 because the true strength of this relationship is that it's what? The real strength of this relationship is that it's what? The real strength of this relationship, and I think Blake sees it right there, 2 is strong, but it's that it has a parabolic form. And the value of R only denotes linear strength. So since there's not a linear relationship, we do not see linear correlation. And we did mention briefly, we do have ways to analyze this with things like Spearman for things that are monotonic. So actually that wouldn't even apply to this. Would you use correlation to analyze the strength of the relationship between this X and this Y right here, where we have a correlation value equal to something like 0.70, would it be proper to use correlation right here? Would it be proper to use correlation right here with this relationship? Between that X and Y that has a correlation of 0.70, and you'd be shocked, yes, that probably does have a correlation of about 0.70. I'll even show you by graphing it out over here. Would you use it? If you saw that here just a second ago, watch as I actually recreate it. And I really think that would have a relationship about 0.70. If we go right here and go boop, 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 make all the points, make it go upward. Is it even gonna have a stronger relationship? Whoa. It's I actually it's even higher than I thought. Maybe the one I drew is it's 0.8 or so. So this relationship here has a 0.79 correlation. Should you use correlation here, yes or no? There we go. Now it's going towards 0.70. Should you use correlation here, yes or no? Oh, we almost did it. There we go, 0.70. No, why? Why? It's not straight enough. It's not straight enough. There's something, a line kind of goes through this data, but it's not the right form for it. So we're talking about the form right here. This is a non-linear form. So like I said, this could have a correlation of 0.70, which we do confirm with the correlation up there, the value of R, but this is not linear, which goes to the form of it. It is a non-linear. The direction is pretty simple. The direction is just positive, negative, or neither. This one is neither. That one's positive. That one is neither really. Doesn't really go up or down. You could say not well described by a direction or doesn't have a strong direction. Negative just means it goes down. The form is going to be linear, non-linear. Or non-linear. When it comes down to it, though, if you look at correlations right here, and I like doing this, if we have a correlation of the following data, what do you think the correlation of these points would be? What do you think the correlation of these points would be? What would be the correlation of those points on the screen? What would be the correlation of those points? Take a guess. What would it be? Correlation is measuring linear strength, positive, linear, and relatively strong. So what would be the value maybe? Closer to a great answer is Lindsay right there. Maybe like R equals 0.9, very strong. And so watch this. When you think about it, remember correlation is how tight the points are around the line. So what if I were to take the same graphic and do the following? Sure, we'll put this all on the next screen. If I were to take the graphic and make the line slope less, what is the correlation now of it? So what do you think the correlation would be of it once we get it back on the screen right here? Really? Where'd it go? If I make it slope less, if I make it slope less, what do you think the correlation of it would be? I think I'm hiding it behind there. What do you think the correlation of it would be if it has less of a slope? Okay, it just doesn't want to exist, so let's redraw it. If it had less of a slope, but it was the same pattern, what do you think the correlation would that be? Well, the slope of the line doesn't matter. It matters what the points are. If these are the same points, just less sloped, the strength of the relationship is how spread out they are around the line, right? So the slope is not part of it. It's how tight they are. So, but what would happen as we pass through and the points then did this? So these are the same points, like at the same scatter points. What would be the correlation here if they have the same scatter? They have the same tightness around the line, but something's changed. What would be the correlation now? Now, and Lachey got it right there. Great job, Lachey. R equals negative 0.9, right? R equals negative 0.9, exactly. So what has remained the same about this relationship right here, denoted by the scatter? What has remained the same throughout all three of these plots? What has remained the same? I saw it right there. I was like, you got it. What has remained the same about those relationships denoted by the scatter? What has remained the same? The what has remained the same? Denoted by the scatter of the points around the line, the what has remained the same? Well, the form is true. Form is true. Lachey got 38,000 points. It is the same form. That is a true answer. All of these have remained linear. All of these have remained linear. So that is true. The line has remained the same. They have all remained a linear relationship. So they've all remained linear. That is true. The strength has remained the same. Because to look at strength, you could just look at the what of correlation. What am I trying to tell you? To look at the strength, you could just look at the what of correlation. That's how we write it in R. To look at the strength, you could just look at the what of correlation. What could you look at? To look at the strength of a correlation, you could just determine it by the what of the correlation. Strength of correlation can be examined by its absolute, its absolute value. What are the strongest correlations? The strongest possible correlations would be what? So if you think about your strongest possible correlations right here, what are the strongest ones? The strongest possible would be what and what? These are the strongest possible linear correlations. One and -1, exactly. Both those answers are what are the strongest because the only difference between these is the what? The only difference between these is the what? The only difference between these is the what? Like, they're still the same strength. They're the same strength. The line does just as well for both of these. They're the same strength. It's just the direction is different. They're both linear. They have the same form. Now, you could throw in some outliers. And what would an outlier do over here to the correlation? What would an outlier drastically do? Like, if we toss that in here, all of a sudden the correlation might now, it's going to do what? Something like that. It could drastically impact it. That's why we say no outliers. You throw in one point right there from that perfect correlation, and we can even mimic it. It probably is 0.60 negative. It's gonna make it a lot weaker. So let's do that. We got like a triangle going on right there. We can mimic that drawing and see what it would do. 5 points with a triangle point. So here's your perfect. Notice how that has perfect negative correlation. We threw a point over here. And ooh, I was closer with that first guess. Good, Natalie, let me know. Oh no, Natalie. You see how that made that a lot weaker over there? So the correlation's a lot weaker. So we were kind of close. I said about 0.4 the first time. I should have stayed with my guess because I said 1 point right there would really wreck it. And my first guess was the 0.40. You don't have to be perfect in your guesses. You just have to understand theoretically what happens. If I remove this point, what's going to happen to the correlation? If this point were to be removed, what would happen to the correlation? It would get water. The correlation with this point removed would get water. If I remove that point right there, the correlation will get water. It'll strengthen. It'll go towards -1. You see it right there. That point right there was weakening the correlation, making it weaker. So you can put any point. You can have weak correlations, make them strong. So for those who don't remember, what can correlation do to your... We got it on here somewhere. We did it in class today. What can correlation... Oh my gosh, too many things. What can outliers do to correlation? What can outliers do to correlation? What can outliers do to correlation? I thought we did in class. I don't know what I did. Anything. They don't impact the median or the IQR. They don't impact those. They also heavily impact the mean and standard deviation. So good review of correlation right here. Also know how to read a correlation matrix. Correlation matrix just show you the pairwise correlations. Weakest correlations have values closest to what? The sign doesn't matter. The weaker a correlation is, the closer its value is to what? Good job, Ivana, right there. The weaker a correlation matrix. I can show one of those too. The weaker a correlation is, the closer its value is to what? To 0. The stronger a correlation is, the closer its value is to what or what? The stronger a correlation is, the closer its value is to what or what? I don't know, survey 10. Here's a correlation matrix. To 1 or -1. So what is the weakest correlation in this matrix? What is the weakest correlation in this matrix? This would be a decent test question. Oh, no worries, Blake. What is the weakest correlation in this matrix? What is the weakest correlation in this matrix? What is the weakest? The weakest correlation in this matrix would be what? What would be the weakest? Ah, careful, careful. So weakest, we're looking for the correlation closest to what? So the weakest, we're looking for the correlation closest to what? 1,000 points. Good work right there. This is why we like to practice right here, because when we look for weakest, you should say, I want to find the correlation closest to 0. Does that make sense? Good work there, Lindsay and Blake. I want to find the correlation closest to 0. Yeah, I know, right? It's so easy to do, right? So once you find your answer, if you're like, my answer is this right here, Then you look and you say, is that low? Oh, that's closer to 0. So as soon as you find your answer, start being like, that one's lower, that one's closer to 0. Be careful. Lower meaning closer to 0, smaller in absolute value. Like you could do something like here. I could probably go and do absolute value on these, and then it would be easier to look at here and find the one that's closest to 0. And I could actually do which dot min and find out which dot min, and probably need to rand equals true. It's the second one, which is that one right there. I need to do a rand. It's like array equals true or something because it's an array. I don't know. It's the second one if you list it out, though. So you can see right here, the second one is the minimum. But I also did, if I don't do the absolute value on it, then it's probably going to give a different answer because the other one's smaller in terms. See, it says 7 now. 1, 2, 3, 4, 5, 6, 7. There it is right there. So the seventh one came back as the smallest, but I should take the absolute value. And I could probably get the position in the matrix. I don't know. There's so many ways you can do this with code. Or you can just do all correlations. Go here and go all correlations of the iris data frame, and there you go. And then you could sort them, sorted by strength. There's the strength sorting. There you go. So the weakest would be towards the center of 0, or you could do magnitude. So I love coding. Magnitude. There you go. So there's the weakest in magnitude. So you notice magnitude sorts by closest to 1 or 0. So the weakest right there is 0. You can see the most negative correlation between them. And this is just a better way to view things than a correlation matrix. It also removes the redundant ones. But that's why we code. So if you're wondering what we do in 320, we do it even better and quicker. Because I can just answer questions like, what's the strongest correlation? Oh, it's this one. I could even report it by going here and say row 1 report. There you go. Does that? Or I could go and say tail. I don't know. I love coding if you can't tell. I could say tail of what I've reported and return the last, and that's the weakest. Off the top of these scores, you do get the scores of honor right after. You should see your scores. Shu, for chapter 1, what makes a term quantitative or categorical? Like, what do both those mean? So if something is quantitative, it is a what? For it to be quantitative, it must be a what? For something to be quantitative, it must be a what? Here, we'll have it here, and then we'll do that. For something to be quantitative, it must be a what? If it's quantitative, it must be a what? It must be numeric, must be a real number. So if I were to collect data on the state you're born in and call like Tennessee State 38, would that make Tennessee quantitative? So if we were to collect data on state you're born in, I say like you're born in state 38, does that mean it's quantitative? That's not a real quantity of state born in. So if something's quantitative, it'd be something like how old are you, how tall are you, how many shoes do you own? Things like can you juggle is categories. Now, what usually confuses people is when we report categorical variables, we report how many people are in each group. Like 10 people can juggle and 5 people cannot juggle. Is that a quantitative or categorical question? Listen carefully here. This is a trick one. 10 people can juggle, 5 people can't juggle. Is that quantitative or categorical question? The question. The graphic, We'll do it real quick here. 10 people can juggle, 5 people can't. It's categories. Do 2, 3, 9. It's categories. Because the question was, can you juggle? And then we are summarizing it by saying 10 people can and 5 people can't. Because if you ask me, can I juggle? I say yes. So chapter 1, variable types and graphics. Head over to the main screen. So the reason we have to know the variable type is because it's going to determine what graphic we use. So you can use the screen to cheat, but if I wanted to graph the relationship between height and weight, I would make a what? If I'd want to graph the relationship between someone's height and weight, I would make a what? So you have to first identify the variable types. If I want to graph the relationship between height and weight, I would make a what? To graph the relationship between height and weight, I would make a what? What would we do? Not stacked histograms. So think about it this way. Height is a what variable. Weight is a what variable. Oh, I'm glad we're doing this. Height is, so start with this. Height is what? Weight is what? So height is this. Weight is this. What is height? What is weight? Good work, Nicholas. Height is weight and weight. Height is what and weight is what? Both are quantitative, right? So then a scatter plot, right? And do you see how this graphic works right here? You say, okay, I want to explain someone's height. That's the y variable of interest. Weight is going to explain it. That's the x variable, the explanatory. So the answer is scatter plot. So you say, what type of variable is my y? And the reason this is blank over here is if you have no, and this goes to univariate displays, if you're not doing a second variable, I usually define my variable as my y variable of interest. So there's no second variable for these univariate displays. Like if someone wants to display heights, they would display it with what graphic? If someone wants to display height, they would display it with what graphic? If someone wants to display height, they would display it with what graphic? Height, just height. Someone wants to display height, they would display it with what graphic? Just a histogram, great answer right there, yep. Histograms, box plots, stem and leaf, dot plots, all those in there could be used. Got the hiccups so often lately. Univariate quantitative analysis, exactly, because you're doing just one variable and it's quantitative. How about if somebody wanted to display the letter grade you made on the test with, did you go to reviews? The letter dot plots, the letter grade you made on the test with, did you go to reviews? Blake's flexing on us right here. The letter grade on the test with, did you go to reviews? The letter grade on the test with, did you go to reviews? The letter grade on the test, mosaic, because letter grade would probably be the thing you want to understand, right? That's your y variable of interest. And then the grade you made on the test is going to be the other one, is going to be the categorical, which explains. So we'd be over here in this thing that I'm blocking, mosaic plots, which contingency tables, which we did today in class also. So the first thing you need to know before making a graphic and choosing your proper graphic is the types of your variables, because depending on it, you'll do different analysis. Logistic regression is when you have a categorical y and a quantitative x. There's a lot of ways to do logistic, but most importantly is predicting probabilities. It's crossed out because we don't do it in 201. We do it in 320 though. What other questions are there about variable types? Like, you basically need to know, like, bar charts and pie charts are interchangeable. You can make a pie chart of your bars, bar chart of your pies. Pareto chart is a bar chart put in order. Frequency table is like when I said 10 people can juggle and 5 people can't. That's the frequencies of observations. If you say relative, it'd be 66% could juggle and 33% couldn't, or 0.66 as a decimal. Ring charts are pie charts with the center cut out. Histograms are going to be, I think we did a really good drawing lately of all of those. Band ring charts. We don't like ring charts here. No ring charts for us. We did a really good, it's on here. I just saw it a little while ago. Was it over here? It's graphic like 36. There it is. So here is a box plot over top of a histogram where we added the dots. And then there is a, we added in dots to this and we made it a stem and leaf. It's not, I don't know if this is a great teaching technique right here to show this craziness we drew. But the stem and leaf is just like, if we ask people how many push-ups you can do, the stem and leaf is just going to show you the observations, where the height of the bin is the amount of observations. So usually you have a count that there's a lot of like 300 plus observations in the bin from 0 to 1 for how many pets you own. A lot of people own between 0 to 1 pets. Is there a special name for histogram? I forget it. Just histogram. So this is just a histogram right here. You can do stacked histograms if you did like how many pets people own versus gender or something. I think we have this data set open. That's the one we made today. Let me open up this data set and I'll show you a stacked histogram here. Okay, here we go. And so if we went here and went to analyze distributions, and then we did gender, so we'll go by gender, and then we'll do number of pets you own, and we'll stack the histograms. And whenever you stack histograms, you need to make sure to give them what? The same whats. And the answer is up here. You want to give the histograms the same whats. Whenever you stack histograms, you want to give histograms the same whats. Whenever you stack histograms, you want to give them the same whats. When you stack histograms, not well, there you have a kind of, we want to give them the same. It's the last word right there. The same this and the same this generally. You want to give them the same scales. The same scales right there. Good answer, Blake. So I'm putting on the scales on these. The count axis is a scale over there. It didn't do the exact same, so you can actually edit these a lot of times. We'll just make it look kind of similar. You could change the bin widths. I want to give it a little more bins. There we go there. I also don't like that it put this. I'm going to set this to 0 because you can't go below 0 pets. I'm going to set this to 0 right here, so that's how I would display my graphic. Sometimes the way Jump does it by default is not perfect, but now we have a much better display of our graphic. Should we compare means or medians for these? Should we compare means or medians? Means or medians for measures of center. Pretty obvious answer right here. Means or medians for measure of center. Means or medians for measure of center. Medians definitely, because it's heavily skewed to the right. Right to the high, left to the low, whatever way the monster man's tail goes. It's so funny. Like, I've had some people who take like other classes and they're like, dude, I totally remember right to the high, left to low, whatever way the monster man's tail goes. Right there. Monster man looking all sly with the right tail right there. So just remembering that median is a measure of center for skewed data is excellent right there. And then the measure of spread would be what? For this data on the bottom, the measure of spread would be what? Right to the high, left to the low, whatever way the monster man's tail goes. It'd be the IQR. And so what is the IQR for this data? You can cheat and go to summary statistics right here and go to customize and find it yourself. This is like, you don't always need to find things on your own. Where is it? It's interquartile range. Where is it? There it is, interquartile range. And the interquarters, it is 2. Notice right here, 0 to 2 is 2. That means the upper fence is at, I'm thinking 3.5. So it might be hard to see, but there's a fence right there. No. It's all right. No, it's at 5. What am I doing? It's right there at 5. That's where the upper fence is at. And that even says maximum excluding outliers. I just couldn't do math in my head because the IQR is 2, 1.5 IQRs is 3, and not that 3, but 1.5 IQRs is 3, which is 5. And it's just ironic that that's right there. So pretty good stuff. 1.5 IQRs above Q3, 1.5 IQRs below Q1 are where the fences are at. Any other last questions to Owen right here as we finish up? I'm going to be checking out emails here in a little bit. I'm going to talk a little bit about univariate analysis in 320. So this still kind of applies. So if you want to hang out, hang out. We're probably going to end off after this. But this is univariate analysis for the 320 class, which is still sort of the same ideas. So univariate analysis for 320. Hoping for the best. You got this. Can we do a practice one of those? Lachey, what do you want to do a practice one of? Let me know. And we can do that here next. What should we do a practice one of, Lachey? Oh, I didn't put a timestamp of that. Let's take a guess. We're taking a guess at this when I timestamp that. Okay, that's a good guess. The IQR, So let's, here, watch this. You ready? Here, we can do it at the 320 level. We'll do a practice one right here. And this will help us understand how to get the IQR. Like if I have right here a summary, and this is how do you do univariate analysis inside of R, we're going to go right here and do a summary of our cars. Can you just imagine that you own a Dodge Challenger? Oh my gosh, if only I owned a Dodge Challenger. So with the Dodge Challenger right here, what is my miles per gallon? Just read the data as is, and then we'll look at the range of these data and such. With my Dodge Challenger, what is my miles per gallon for it? We went and recorded some cars. What was my miles per gallon in my Dodge Challenger? So that's the name of the row we're talking about. So just look at the data and be like, oh, you got this much miles per gallon with your Dodge Challenger. And we're just making sense that we know. It is way more than 150 horsepower. What is the horsepower of a Dodge Challenger?
Here's what I found from Finder.com.
It's 840.
The Challenger is a pony muscle car that puts out up to 840 horsepower.
What is this data set then? Blake, I didn't even know that. Blake is like, what in the world is that? Blake's like, your data is wrong. Blake, we got to throw you 2,000 points. Didn't even know that. I should take a look. We can actually write a question mark at any time inside of R to question things. Blake, amazing find right there, being like, what the world? Stretched from 1974. Okay, so now we need the 1974 Dodge Challenger. 1974 Dodge Challenger horsepower. 1974 Dodge Challenger horsepower. The 1974 Dodge Challenger, and it looks like it's still higher. 1974. So right here, they're saying 245. No, everything's saying higher. Everything's saying higher. Wait, look at it. Ooh, there it is right here from Muscle Facts. From Muscle Facts is saying 150. So I don't know, something weird, right? Data's inconsistent. There's another one saying different numbers, right? So Blake, you were right. Dodge Challengers at least today are way different. Yeah, exactly. And that's the thing. So what's really cool is we can put a question mark in front of the data frame. And I didn't even know it was from 1974. We should probably know what we're analyzing, right? 32 different cars, 1973 through 1974. There's even a Lotus right here. I'd love to get a Lotus. Maybe I'll get that. That's a kit car right there. You make it from a kit. So it's in a show called The Prisoner. So yeah, so these are less powerful cars right here. How do we calculate the upper fence? We can do that right here. Let's do that. Let's look at the univariate analysis of this, and let's take a look at some data right here. And this, so once again, if you're in 201, this still applies. Like these concepts and the way we're doing them are just a little different. It's still the same idea. What am I showing you right here? What am I showing you on the bottom of the screen for the cars? This is univariate analysis. A lot of this right here is the what currently on the screen. A lot of this on the screen is currently what? What do you currently see? Most of this, except for the mean, is the what? Most of that, except for the mean, is the Lamborghini. I don't think it is. I don't think I've seen it in there before. Most of this, except for the mean, is the what? And we could even do this to narrow it down. Most of this, except for the mean, is the what? Most of that, except for the mean, is the what? What are these numbers known as? I'll give you a hint by drawing on it. These numbers right here, the quantiles, there's 5 of them. So what? And great job, Lindsay, right there practicing. These numbers right here on the screen are known as the what? We do a lot of review at 201 and 320. So if you remember 201, you go to 320, you're like, yeah, that's the 5-number summary. And they're known as the quantiles because the 50th percentile. So watch this, median. And this is what's so cool about code. You could just write right here, median. And it's the same number. Just tells you the median. Go ahead and find me the IQR. Find me the IQR. You find it the hard way. I'll find it the easy way. You'll see why I love coding, because it's like, why find it yourself when the code just finds it for you? Makes you a little bit lazy when you're doing work, because you're like, the code will just find it for me. I don't need to subtract numbers anymore. So the IQR is the range of the middle 50%. So when you think about conceptually right here, you're asking the range of the middle 50% right here. So it's going to be the distance those numbers are away. So let's check your work. What do you think I would change median to? Hint it's capitalized. To write the code to get the IQR, what do you think I'm going to do? I'm taking a vector of information and I'm running a function on it. So what do you think I would just change this to find the answer? And we can check your work. What do you think I would do right here? Just be like, just change what the thing I'm running on it. That's the thing I'm running. I'm running the median function on it. To say, give me the median of this. Why don't we just say, give me the IQR? There you go. Just give me the IQR of that. Does anyone know how to say, give me the range of this data? Which the range is going to be about 23.5. What do you think I would do for 1,000 points? Just be like, give me the range of that data. Hint, this one's not capitalized. And if you're ever confused, you can type 3 letters. So watch this. What do you think I'd do? Give me the range of that data. Just range. Great job right there. As you say range, and you know right here we can just click it and then run it, and there it is. There's the range, the min and the max. So you've got the range of the data right there. If you don't want it to look like that, you could take the range of the second value, because these are 2 values in a list, or excuse me, in a vector, not a list, and subtract them, and there's the range right there, just subtracting the 2 values. And don't forget about outliers. So what should we do to this to see if there's outliers impacting this? What are your ideas to do to this data, because it's quantitative, to see if outliers are impacting it? So you're doing 320 right now. So now we want to look at this, right? So we should probably make a what? We've got miles per gallon of car. We should probably make a what? We should probably make a what to look at this. I'm not blocking anything important. This is how we do univariate analysis. And we would want to talk about that right here and talk about the mean and the median. And we probably want to know which one's the best to talk about if it's skewed. We could do a box plot. So let's go right here and go box plot of empty cars and miles per gallon. And there you go. There's a box plot. If you want to make a histogram, you go right here and you go hist. And there's the histogram of it. Now, we like to make pretty graphics here. So let me check out, and I bet someone's got a cheat for this. The best site, ggplot, histogram, and box plot on top of each other. In R. Okay, I think someone's already done it over here. I've already found it. Whoops. Here we go. Someone has already done it. We're going to make a graphic that looks like this. Does that make sense? We're going to make this graphic right here, this PERT graphic. They got that all stretched out right there. Oh, here's the answer. Someone answered how to do it right here, and I think they're showing different ways. And then here's their... Does this graphic look nice and purty to you right here? What do people think? Nice and protographic? Let's go grab it. Okay, so their code, they're using patchwork to patch them together. We'll do that afterwards. They're using GG Arrange to do it. This is the main code right here that they wrote. It seems really complicated, but we just have to look at the components of it. So this is our code that we're taking. Now, libraries are things that help you out inside of R. So all this right here is basically done for us. And I have the library dplyr, which is data manipulation right there. I have ggplot2, which is for graphics. And you can always do a question mark on dplyr, and it'll tell you all about the library and what it is, a grammar of data manipulation right there. Or you could see, right, the grammar of graphics is ggplot2, and it's part of the tidyverse thanks to Hadley Wickham right there. So right here, we have a data frame that they've created. Then they have the value that they're using. So our data frame is called what? Does anyone know what our data frame is called? Does anyone know what our data frame is called? Our data frame is our Excel spreadsheet. 1,000 points. We're throwing big points out here. You're doing 320 work if you're doing this. 1,000 points. What is our data frame called with this code that we're using right here? What is our data frame called? Our data frame would be called what right here? We've escaped 201 with the idea of data frames. It's just an Excel spreadsheet or jump workbook or jump spreadsheet. Our data frame is called empty cars. So that's the name of our data frame right there. They're piping it in here to select a certain variable. And so now we need to change the variable name to, we're looking at miles per gallon. And that's the value right there. We could also check. We should have done a search. See value right here. Let's control find, replace value with that, two occurrences. And then the data frame, replace this with empty cars. Okay, there we go. Everything's been replaced. I think that should do it. Please work. Please work. Error in select. Cannot subset columns that do not exist. Okay, so it's trying to select a column that does not exist. Oh, there's ID. They had an ID. That'd be like the names. Names, empty cars. Okay, that worked. So they had an ID or something. Now we have our plots. Let's see if our plots were created. And they call it plot 1, was it? There it is, plot 1. Plot 2, cool. Now we're just gonna merge these two graphics. And let me add to plot 2 plus GG title MPG for 1974 cars. And there's plot 2. Let me do easy center title. And there we go. Oops. Oh, there's plot 2. There's that. And so now let's go and merge the graphics with, I prefer to use, they're using patchwork. I prefer to use GG Arrange. Let's see right here. Whoops. And there it is right there. I'll do it. No, I don't want it to look like that. Height 1, 2. No. Is it rows? Let me look at GG Arrange real quick. Question mark GG Arrange. I want it to be on stacked. No, end call we want. Number of columns. Number of rows. N row equal 2. What? Oh, no comma. That looks pretty good. We can we can make it look like jump. But then we want the title up there. We'll put it back. What do you think? And then we might, I think there was the other argument that I saw, which actually can change the ratio of them, a 2-to-1 height ratio. So now let's change the ratio of it here. Nice. Wow, I like it. Oh, that didn't change it. That's weird. So we need to go smaller. What? I'm so confused. We'll do 2 again. I would say this is pretty darn good right here. We definitely have an outlier, but for all the work we did right here, what do you think? Pretty good graphic. I would say we have our histogram and box plot, And this is the kind of analysis. You can see the one outlier over here that is far enough away. That observation right there, which is 1 point, it looks like, from the relative frequency. Is it type equals absolute in the... Let me see right here. The GG histograms graphic 2. So identity... How do I change? Relative frequency. No, it's already labeled. Theme classic. Fill light blue. What questions do you have? Fill FF82. FF8200. And Phil FF8200. There we go. Got some Rocky Top. Good to go. I'd say for the amount of work we put in, we got a really great graphic. And that's what we're here to do. So if you think about this, I'm a big proponent of, make some amazing graphics. Truthfully, that I know that's going to look really good when we talk to people about it and say that there's an outlier. We can see where the IQR of the data is. The fence is going to be somewhere in between here to here. We could figure out exactly where it's at. We see some slight bimodality. You notice right here, there's a small group of points down here, but not outliers necessarily. But there's a peak over here around 15 miles per gallon and a peak over here in the lower 20 miles per gallon. A little bit of scatter. So I'd say there's some slight bimodality right there. And that's really going to be some of your best univariate analysis. And if you notice, here's the stat tool 1 thing. What do you notice is hidden in the box plot for 2,000 points to end office hours? Oh, wait, wasn't there another one? Didn't someone else have another question? What do you notice is hidden in the box plot? What do you notice is hidden in the box plot, which I just mentioned? What do you notice is hard, you wouldn't really notice in the box plot down here, which is more apparent in the histogram of it? This is the same data. It's just being displayed as a histogram versus a box plot. Yeah, Hunter, we talked about Pearson versus Spearman. What is hidden in the box plot that is more apparent in the histogram? What is hidden in the box plot? Oh, no worries. The modality, Blake, exactly. So the histogram is going to be better at showing you shape. Box plots only really show you very well the 5-number summary. So the modes right here, you don't really see the peak inside of here or the peak inside of here. You just see here the min, the Q1, the median, the Q3, and the max. And that's the highest point that's not an outlier, which is over here related to that point. So all this good stuff right here. Yeah, so this is a very good visualization. And if you look, we went from doing some pretty simple code to some more complex stuff. But each one of these just does a little thing for you, like adds a theme. Oh, you can't see it. Adds themes, adds labels, does different things to the elements right there, adds the ticks and all those good things right there. GG title right there. Yep, we added that. We added a center title. We put it to theme classic. There's a lot of different themes you can use, like theme black and white. Now we just totally made a different thing. You know what? Kind of like that. Kind of like that. Kind of like that little grid on there. So yeah, pretty easy to make some changes. The theme's already set for you. I might not like that goes outside of it. Probably need to add a coordinate on the side. No, that wouldn't matter. There's no height scale. We could put it side by side. No, you want them stacked like that. But all this right here is just practicing and making better graphics. And so yeah, might drop this all into the Discord right here. So I used one other package. I used library GG easy. I want to run, let me remove the question mark. Move the plot 2 and drop this into office, or drop this into 320. 320 is chatting away. Graphic from office hours. Any questions you have? Okay. Still doing all right there. Checking out there we go. Got that solved. Good stuff right there. You're welcome. Spearman versus Pearson. Spearman versus Pearson. Let's take a look over here. So when we do Pearson only applies to correlations between what and what variables. When we do Pearson only applies to relationships between what and what variables. Pearson only applies to relationships between what and what variables. Pearson only applies to relationships between what and what variables. Pearson is only for what relationships. Pearson is only for what relationships. Pearson, the relationship must be this. You need to start with Pearson. This is 201 also. If you're talking about Pearson, you need to be like, I need to be looking out of this relationship. So if it's Pearson, it needs to be a this. This is 201 applicable. If it's Pearson, it would need to be what? You might see an issue with this right here. If it's Pearson, it needs to be what? What is the key thing that all Pearson relationships need to be? And I'll show you this a different way, and you might pick up on some of the issues with this model. What is the key thing that all Pearson relationships need to be? All Pearson relationships need to be what? They need to be linear. Do you see that if we put a polynomial through this, there is a non-linear relationship to this? The line does okay, but putting a polynomial model through this data shows that there is probably better polynomial strength. We can increase the degree of polynomial we put through to have it bend more, and I don't know the exact degree we should use, but definitely adding polynomial bends through this helps. So you can see it in the original data with the associate command that there is some sort of bend to this data. So that means maybe we shouldn't use Pearson, we should use what? Due to the bend in the data, maybe we shouldn't use Pearson, we should use what? Because the data shows a non-linear relationship, maybe we shouldn't use Pearson, we should use what? Maybe we shouldn't use Pearson, we should use what? Since it shows a nonlinear bend, you're welcome, Lachey, excellent work. We should use Spearman. Spearman is for nonlinear relationships, but it must be monotonic. So we were talking about this earlier. When it comes to Spearman, it must be monotonic. Spearman is meant to handle all the issues. I think we have one. I thought we had one for it. Spearman is really meant to handle all the issues that Pearson has with things like outliers, it not being straight enough, heteroscedasticity. So Pearson is really your end-all be-all solve for weird things that Pearson can't deal with, except it must be monotonic. So if you have something like outliers, well, Spearman says, who cares? If it says,
It doesn't matter.
if you have something like nonlinearity, Spearman's good with that. If you have something like heteroscedastic, which means the plot is getting thicker in some spots, it could get thinner again and then get thicker again. This is heteroscedastic. Then Spearman is good for all of these. So every single one of these right here is a possible Spearman relationship. Spearman is handling the issue of outliers, it's handling the issue of nonlinearity, and it's handling the heteroscedastic relationship right here. But the one thing Spearman is not meant to handle is Spearman doesn't work with non-monotonic data. Monotonic meaning it goes in one direction, so Spearman does work for monotonic, but as soon as it starts to change direction, really, Spearman is not the right idea for the data. At that point, we'd be going towards things like polynomial models. So when do you want to use Pearson? Pearson is used for what kind of relationships? Pearson is used for what kind of relationships? Pearson is used for relationships that are what? They must be what between each other? The two variables must have a what relationship? Linear. Because Pearson only measures linear strength, measured between -1 to 1, with those ends being the strongest, 0 being the weakest. So you can easily have relationships that are, we could look at one. Here, let's go do one real quick. Core demo. And got to go to the actual size right here. Control 9, didn't even know that. And so here, this right here is going to have weak correlation if I do it far enough out. But all in all, it probably started to go down right there. That's not good. That's not that weak. See, I'm wrong. I can be wrong about stuff every once in a while. It has 0.8, but it's much better as a Spearman because the Spearman correlation on this is going to be even higher. Because this has some sort of polynomial relationship right here, as the rank of X increases, the rank of Y also generally increases. We got that little dip at the end, which scares me. But if you have questions, please post them on the Discord as soon as possible. Jump in here to office hours, ask anything you're wondering about. Be here for the conversation. I'm going to be checking out the Discord. A lot of people have been posting questions. People People are wondering different things. People are trying to knit and get their documents going. With that, it's the end of office hours. Good work, everybody. I'm going to post the notes for this right away. Bye for now, everyone. Bye. Good luck on the test.